Alright, welcome everyone. My name is Dwight Duffy, and in this tutorial we're going to review the basics of binary arithmetic. How does a computer actually perform arithmetic, addition, subtraction, multiplication, division, on binary values? It's an interesting question which really gets to the heart of how computers actually process data. If you think about it, computers primarily process numeric data. Photoshop takes RGB values, red, green, blue, numeric values, and transforms them, maybe adds an extra red or changes the contrast or saturation by mathematically changing the values of the different color values. If you think about a spreadsheet, spreadsheets by definition are doing math transformation on numeric values. If you think about a video game, you have in 3D, X, Y, and Z values, which are being transformed mathematically through math formulas. So pretty much everything that we do with a computer is arithmetic. And the computer stores these values in binary, and we've looked at how we represent numeric data in binary. But in this tutorial, we want to actually understand how the computer actually transforms binary values arithmetically. All right, so we know that the number 7 decimal would be represented as turning on the 4, the 2, and the 1. Remember, in binary we have each column is doubled, so we have 1, 2, 4, 8, 16, 32, 64, 128. So 7 would be represented as a 4, a 2, and a 1 turned on. So if we wanted to do arithmetic, let's take the simplest possible sort of example, or pretty close to the simplest one, and let's add 2 and 3. So I've got a 0, 1, 0, which is the 2 is turned on, and I want to add up a 3, which would be a 0, 1, 1, which would be 2 plus 1, or 3. So I'm adding up 2 and 3. And never mind that we know that 2 and 3 is 5. Let's just see how the computer actually treats this and how the computer looks at this. Now this doesn't answer the question how the logic actually works, but it lets us understand what the logic is. So if we have no 1 and we have a 1 turned on and we add nothing plus 1, we're going to get a 1. So a 0 and a 1 is going to give me a 1. So that's kind of the first rule of binary addition, is a 0 and a 1, or a 1 and a 0 is always 1. No remainder, no carry, just a straight 0, 1 yields me a 1. Now, a 1 and a 1 is going to give me what? That's 2 and 2. 2 and 2 is 4. I can't represent 4 in a 2 column. The only way I can represent a 4 is to move over to the next column. So a 2 and a 2 means that I have to give up on the 2's column because it's too big, right? So I put a 0 in the 2's column, and then I carry a 1, which means I'm carrying a 4 to the next column. And so now 1 and then 0 and 0, of course, is a 1. So 4 plus 1 is 5. And then, of course, all the rest of the columns here, 0 and 0 and so on, gives me 0. So 0 and 0 gives me 0. A 1 and a 1 gives me a 0, but we carry a 1. And then a 0 and a 1 is a 1. And a 1 and a 0 is a 1. Okay, let's do one more. I'm going to do 6 and 8 because I think this is going to be a good illustration of all three rules in play. So a 6 would be a 4 and a 2. Agreed? That's going to give me 6. And then I want to add up an 8, which is going to be a 1, 0, 0, 0. So 6 and 8. And never mind what 6 and 8 actually is. What we want to do is actually use those three rules that we just described. 0 and 0 is always a what? A 0. Always, always, always. It doesn't matter what column you're in. If you have nothing and you add nothing to it, you still get nothing. So that is the same as binary. It's the same as decimal. If you have a 2 and then we add nothing to the 2, we still have a 2, so we have to turn on that bit. Same thing here. If I have a 4 and I add nothing to it, I still have a 4, so I have to flip on the 4. So a 1 and a 0 is still a 1. And then here I've got 0 and 1 is still going to be a 1 because I have an 8. And now I have 8, 9, 10, 11, 12, 13, 14, right? And that adds up to 14. All right, I'm going to do one more, and this one's just going to be, I have no idea what the answer is going to be. I don't even know what the values are going to be. I'm just going to pick a couple of numbers. I'm going to pick 22, and I'm going to pick 17. And I'm going to pretend like I don't know what 22 and 17 is. I'm not that good with math anyway. So 22 would be looks like a 16, and a 4. That takes me to 20. And a 2 and a 0. So that's 22. And 17 would be a 16 and looks like just a 16 and a 1. So 0, 0, 0 and then the 1. Okay, so I'm going to do binary arithmetic. Remember the 3 rules. 0 and 1 gives me a 1. A 1 and a 1 gives me a 0, but a carry of 1 and 0 is always going to give me a 0. All right, so here we go. 0 and 1 gives me a what? A 1. A 1 and a 0 is a 1. I don't have to worry about any carry. A 1 and a 0 is a 1. A 0 and a 0 is a 0. Dang, this is easy. And a 1 and a 1 is a 0, but we carry a 1 to the 32 because remember 16 and 16 is 32. So I can't turn on the 16 and I carry the 32 by carrying the 1, and then I just have essentially 0, 0 here. And so 1, 1, 0, 0 gives me a 1. So the answer is actually 32 plus 4, which is 36, plus 2, 38, plus 1 is 39. So I'm going to have to say the answer is 39. All right, so kind of fun to be able to do binary addition. And what we're going to be looking for in the next tutorial is a way to actually, using logic gates, program those 3 rules. That 0, 0 gives me a 0 with no remainder, a 0, 1 gives me a 1 with no remainder, and a 1, 1 gives me a 0 with a 1 remainder. If we can program that, then we actually have a little program or a circuit, a digital circuit, that will perform just simple binary addition. And then we would need another program to do subtraction, which is going to be very similar, and another program to do multiplication and division, and then floating point addition and subtraction, or multiplication and division, is going to require a little bit of a different program. So all computers kind of share these programs, and these programs then become part of the, the Pentium chip or whatever the processor is that's going to actually perform the calculations that the computer does. Okay, so that concludes the tutorial on binary arithmetic.